Let us identify the different relationship of lines. Two lines are parallel if these two lines will never meet however far they produce. Two lines are said to be intersecting if they will meet at exactly one point. Perpendicular lines are also intersecting lines, but their intersection forms an exactly 90 degrees or a right angle, while coinciding lines are actually two lines that overlap each other. So in a given linear equation, how do we know if their graphs are parallel, intersecting, perpendicular, or coinciding without even graphing them in a Cartesian plane? So by just observing the equation, we can identify. So let us try these two sets of equation. So this is the first set of equation. Look at their lines. They were parallel. While the other two lines, they were also parallel. What makes them parallel? Observe their slopes. Since the equations are in the form y is equal to mx plus b, so this is the m, the number beside the x, which is our slope. The slope here is negative 5/3, while the slope on the other equation is negative 5/3 also. So they have the same slope. That makes them parallel. The same with the first set of equation. They have the same slope. The slope here is 2. The other equation has a slope of 2. That is why their equations are parallel. So we can conclude that if the slopes of the two equations are equal, then the graph of the lines are parallel. So we have another two sets of equations here. So let us identify them. So this is the first set of the equations. If we're going to graph them, there's an intersecting point. So they intersect. How about the second set of equation? They also intersect, but they did not make a right angle, so it is not a perpendicular. It is just an intersecting line. So observe their slopes. This one is negative 5/3, and this one, the slope is 1. So they have different slopes. How about the other given? The first slope is 2. The second slope is 3. So they have different slopes. So we can conclude that it is the slopes that make the different slopes that makes them intersect, because if we're going to make this plus 3 the same with the other one but different slope, still these two lines intersect. So it is not the y-intercept, but it is the slope. So we can conclude that if the slopes of the equations are different, then the graph of the lines are intersecting. So we have another two sets here. Let us graph them. So look at the result of their intersection. It forms a 90 degrees. So we can call this as a perpendicular lines because they intersect with a 90-degree angle in their intersection. So we have here another set of equation. So again, they intersect, but it forms a 90 degrees, so their intersection is called a perpendicular. So these two lines are perpendicular. So what makes them perpendicular? Observe again the slope. So this is 3/5 and this is 5/3. That is the reciprocal. Look at the sign. This is positive, this is negative. So the signs are opposite, the slopes are reciprocal. In the other given, this one is 2/1 and this is 1/2. So they're reciprocal. This is positive and this is negative. It's the opposite. So we can conclude that if the slopes of the two equations are opposite reciprocal, then the graph of the lines are perpendicular. Last set of given. So if we're going to graph the first set, look. This is the blue, then this is the red. Notice that they're just in the same line. So these two lines are coinciding. What makes them coincide? So look at the given equations. They're exactly identical. How about these two given equations? They also coincide. They also overlap each other. But notice that the equations are not actually the same. The intercepts are the same. the plus and the x, the y, while the slopes are not. But if we're going to look closely, this negative 2/4 can be reduced into negative 1/2 if we're going to write 2/4 in its simplest form. So it means they are still equivalent equations. So we can say that if the two equations are equivalent, then the graph of the lines are coinciding.